Good afternoon, everyone. Welcome to today's webinar, which is on thermal comfort. It's hosted by the Air Academy. As we go through this presentation today, we'd like to take questions as we go. So there's a Q&A button in Zoom. If you press that, send your questions in, they'll come through to me, and we'll take some questions as we go, and then when we get to the end, we'll also take additional questions as well. And I'm joined by two of my colleagues here, Mikael and Åsa. Do you guys want to introduce yourselves? Mikael, if you
Yeah, of course. Thank you, Josh. Glad to be here. So my name is Mikael Börjesson, work as the head of sustainability, competence development, and also external relations, so working with industry associations around the globe, actually, in reality, for the group of Swegon.
Yeah. And my name is Åsa Norén-Lundh, and I work for a Swegon Group as an indoor environment competence center manager. And I have a background as a product group manager within Swegon with the room units and talking about the room comfort.
Yeah, good.
Fantastic. Thank you, Åsa. But today we're talking thermal comfort, and Åsa's going to get us started.
Yeah, thank you, Josh. So today we are going to talk about thermal comfort and what affects it. And of course, we have some different parameters that is influencing the thermal comfort. And one of them is, of course, temperature. And that could be the air temperature in the room, but it's also temperature from all the surfaces surrounding us in the room and the operative temperature. And we'll talk more about that during this webinar. It is also about air velocity, of course, in the occupancy zone. So we'll also reflect on that. And also relative humidity, how high humidity we have indoors and compared to outdoors and so on. But can we make everyone satisfied? We have some theory behind this created by Frenger for a long time ago. And we have something called the PPD, that is the perceived percentage dissatisfied. And that is a U-curve that correlates to something that we also called PMV, predicted mean value. And those are correlating to each other, that the U-curve shows that even if we have the perfect design temperature, some people, 1 out of 20, we normally calculate, will be dissatisfied with the indoor climate. So, but we will try and inform you during this webinar how you can achieve as close to that figure as possible to get around 80–90% satisfied, and what you should consider when doing that. So we start with the temperature. In the wintertime, the air temperature when you work in an office and you have a normal activity level for an office work, should normally be set around 20 to 24 degrees. And then also, if you compare that to the summer temperature, we can allow the temperature to be a little bit higher, because we don't want a discomfort, too big difference between the outdoor and the indoor temperature, because then we feel discomfort. So we can allow it to raise up to 26 degrees. What should we more consider? I think the heat loads is also very important, and that is also referred to what kind of work is what an activity you are doing in the office space or in a gym and so on. So here is an example of a diagram that shows different heat exchange that we do with the environment, and you can get an overview over the activity level. And we have some different human heat exchange. We have heat emission through radiation to surrounding surfaces or to free space. And we also have heat release by convection to ambient air, and heat release to evaporation of liquid, which is mainly done by sweating or evaporative delivery. If we bring an umbrella into the entrance, it will bring moisture into the air as well, and so on. And we even have a fourth form of heat exchange that can occur, and that is through conduction to solid or liquid particles in direct contact with body surface. But that is a very small part, so we don't take that much into consideration. So if you look at the diagram here in the picture, you can see that there are different colors. depending on what kind of heat exchange that we have. So if we compare number 3, which is normal office work, and compare that to light body work, you can see that the evaporative, the yellow part of the diagram is much bigger. So depending on what kind of activity you have in the building or on that floor, you could consider different ventilation principles or different cooling needs.
Also very interesting to see that painting is a very energy-giving.
That's apparently very hard work.
And we can discuss what kind of painting we're talking about.
Yeah,
But that's another issue. So then moving further on then.
Yeah, and one other thing that we think is very important to talk about is actually where do we measure when we design an indoor climate? Because I think we tend to forget that when we as end users are using the space and maybe sometimes complain about the indoor climate. But if you design an indoor climate, you always try to design a good climate in the occupancy zone. And what is that really? It could vary a little bit depending on which market or country you are in. But we have an example here from Scandinavia. So what the surface or the zone that we are trying to climatize is from a horizontal plane from 0.1 meter above the floor up to 2 meters above the floor. And on the sides, if you look around in the room, for the inner walls, it's 0.6 meters from the walls. And when you consider a door opening or from the window, it's even 1 meter. And that could have a big impact, Mikael. Have you had any examples?
Good question, because I actually remember back in, I think 1.5 years ago, we had a discussion with a client actually that we're in the building. It was a glass facade. We will come back to the facades later on in this presentation. But they actually furnitured the room, so they used all the space all out to the window. And it was actually a real complaint from the user in the building by both draft, but also the cold coming from the transition from the window itself. And of course that could happen, but during that the occupied zone is there, the design is not allowing us actually to use that kind of surface. Exactly. So that's a very interesting
because a lot of engineers and consultants use that part of the room to take down the air velocity before it enters the occupancy zone to create a good climate.
But I think there it's very important then to be very active in the project discussion to understand how the customer in the end or the user in the end want to use the room. And then if possible, then try to make a design that is allowing you to use spaces that is outside of the occupancy area.
Yeah, and of course we know that you want to change the layout in the office because that's the only thing we know for sure that it will change. For sure. But try and then keep it within the occupancy zone and be flexible with the office layout in that space. But if we also should talk about the room and what is influencing and the heat sources and so on that we need to manage. How can we avoid calculating in the wrong way to if we over design is not so good either, because then it's hard to keep the thermal comfort in a good way.
Yes, so let's move then into the room and look a little bit more what is happening inside the room and what we need to consider to be as accurate as possible in reality. So what is influencing the room itself, the comfort in the room by different kind of parameters, and one for sure very easily recognized. I think you all recognize the fact that we have an effect when the sun is shining into the building. You can easily exemplify that by sitting in the car and having 21 degrees on your AC. And the sun is really shining in, and you will feel hot anyway, no matter if it's 21 degrees in the car or not. So one particular important factor is actually shading. So work with solar shading will help us to achieve a good comfort within the room. As well, to understand, of course, what kind of influence do I have of the components in the room. such as lighting. If you compare lighting today to 10 years back, of course, there's a big difference in the amount of heat load that comes from lighting, but you can still feel it when you're, for example, in a shopping mall, going into an office, or sorry, a shop for shopping clothes or whatever. You feel the spotlights immediately affecting your body, and so there is a heat load factor that we need to consider also within having lighting in the building. Now with the new modern LED lighting, it's not affecting us so much, but we don't know that. We don't know exactly normally what kind of lighting that are very early in the project. So that question needs to be kind of treated in some way.
And I guess also we have demand control on the lights as
Yes,
well nowadays.
True,
So that is also
so even better in that sense.
Yeah.
Yes, even better in that sense. We also, of course, need to consider all other stuff that we have in the office. It could be laptops, it could be screens, it could be printers, it could be copy machines or whatever. All those are actually adding heat into a room. The modern laptops, the modern screens are quite friendly in that perspective nowadays, but it's a factor that we need to consider as well when we're designing the indoor comfort. As well, of course, laptops connected, of course, to how many people there are in the room as well. And the people itself, we actually also produce heat loads into the room and needs to be handled and treated in that fact. So we know the designing value for how many people should be attending this room or this building, depending on what it is design question we asked for. Yeah. One thing that is very important is, from the room perspective, what we just talked about is to also in realizing that we, as the car example, we are not talking just about the temperature, we're talking about the temperature and the surroundings, the surrounding environments. Normally it's kind of, could be floors, ceilings, etc. And the combined mixture, the combined temperature is what we call operative temperature, and you touched into it already in the beginning. And operative temperature is really the thing that we need to consider, because that is where people will judge their comfort based on. So we cannot just look, and not even just the radiant temperature, which is what comes from the surrounding levels, but or not just the air temperature that comes from the diffuser or whatever. It's the mixed temperature that we are interested in, the operative temperature. And by calculating the operative temperature, you need to understand what kind of floor, ceiling, walls do you have, what kind of windows do we have. And we will come back to that a little bit later on as well, to describe and discuss a little bit how big impact does that have, and how should we consider that into the discussion regarding designing good comfort indoors. Yeah.
And another factor that also affects us is the clothes we are wearing. This is quite easy to understand that if you have someone in a suit and a shirt, then they're quite well dressed and they will not be so sensitive towards temperature. But if we have, for example, women in summertime who has a light blouse or a skirt on, then they have not 1.0 glow as we normally refer to a normal male dressed person. And that could be something that complicates things if you have a big office landscape and you have a mix between women and men, and in summertime that could be a source of conflict because everyone wants a different temperature. So in that case, you should also consider maybe to divide the climate into different zones when we are now working in more hybrid office space to get as many people as possible satisfied with the indoor temperature.
That's good.
And if we look at the temperature, the operating temperatures that we were talking about, and we look at what is the best setting, if you have a dress factor called 1.0 glow, which is more of a suit, not maybe a fur in that case, then to achieve the highest quality of indoor climate, which is TQ1, when you have like 90% satisfied in the room, then you should have between 20 and 24 in the wintertime. And if you have TQ2, which is the next highest level, you will have like 85% satisfied in the room. Then the temperature should be between 20 and 23 degrees in the wintertime. And if we then look at the corresponding figures for the summer case, where we have a little less clothes on, then we see that the temperature range is not that big, because we will be more affected by the temperature here and the deviations. But then you should keep around 23 degrees to get the highest ranking or classifications, and then TK2 you have a span between 23 and 26 degrees.
So what you just say, yes, there are guidance to fit the right comfort depending on what kind of quality you want to achieve in the end.
Exactly. And of course we have some days during the summertime when the outdoor temperature maybe rise even above this. Yeah. So it could be also something sustainable to also monitor the outdoor temperature and maybe raise the temperature even more to save energy and also keep everyone happy, because if it's too big difference between outdoor and indoor, we will also feel uncomfortable.
Yeah. Good. And that's also mentioned that to point out that it correlates to the cloth factor, the dress factor. So that has to be in consideration also depending on what kind of users that would be in the building.
Exactly. Yeah. So if we then look at the air velocity, that is also a very important factor not to feel discomfort. Then to achieve the highest classification, you should be around 0.10, 0.15, which is very, very hard to achieve. Sure. Here in Scandinavia, we aim normally for 0.2 meters per second to achieve a very good comfort in the room when it comes to not creating draft.
Yeah.
That's hardly noticeable.
And coming back to, you mentioned the occupancy zone before. This is also a part where you actually, if you have products that are suitable for adjustment of the air pattern, you can directly prevent draft by handling air pattern in a different way.
Yeah, so I think also the room products are really important that you consider not just putting up a simple diffuser, but it should also be flexible or an induction unit or whatever you want as a system. That if you put up a wall or you change your furniture, that you could change the air direction, maybe even change how much air comes out in each direction if you have like an induction unit.
Yeah, and that could help, of course, this air velocity.
Yeah, could be a very good investment compared to handling complaints.
Yeah, that's a good comment.
Yeah. And I think even next week we'll talk a bit more about actually selecting the right room units and which ones to use and where and why and so on.
Then we talk about ventilation principles.
So you already put a cliffhanger in.
We have already,
that's good.
Yeah, and then if you also are talking about the room products, it's also very important to see to that you avoid something called vertical temperature difference or stratification. So it means that the temperature difference from 0.0 up to 1.1 meter in the occupancy zone should not differ too much. And there are some also guidance here, which classification you are aiming for to achieve. And so preferably it should not be bigger than 3 degrees here to not feel discomfort. So if the difference on 1.1 meters differs too much from 0.1 meter, you feel discomfort because we are very sensitive to different temperatures depending on.
So what that means in reality, we need to be very we need to have control of the mixing ratio in the room all over, I guess. Yeah.
So we want to have as even mixture of the air as possible when coming out of the product and as quickly as possible.
This is interesting. I'm not sure everyone is realizing this.
Yeah,
so this could be the reason for a complaint, actually.
Yeah, it could be. Yeah. And then especially also if you try to heat with a product that is installed in the ceiling, because that is also possible. You should see to that you have a good performance when it comes to mixing with the room air, and maybe not even use too high temperature, even if you instinctively want to have as high temperature as possible, like you have on your radiator. For a water-based induction unit, for example, you should keep the temperature like 35-45 degrees when heating, because then you will have a very much better mixing with the room air. So the difference between the room air and the supply air from the unit will mix better and faster.
That's a good idea. And I guess that might come back next week, but also in the discussion of ventilation and ventilation ratio. Yeah, good.
And how do you do? How can you achieve this, and how can you be sure that you have designed it in a proper way and use the right units? Then you can check this also in different tools. And one tool that we use in Swegon is CFD calculations. And in this picture that we are showing now, you can see the temperature of the air in the room, and you can see that it's very good temperature settings in the room. It's very even and green all over. And this means that we have small gradients and very even temperature in the room from 0.1 up to 1.1 meter and even further here. And you can also see the temperature is a little bit warmer at the extract air and also above your head normally, because you generate also heating, of course. And if we should then see how we can check the air velocities in the room, you could also do that by calculating in a CFD. And here you also want as small gradients as possible. And as you can see from the scale below the picture, that the room is fairly much blue or white, which means that it has a very, very low air velocity here. And the high air velocity is above our head because we have like a chimney effect when sitting in the room, and the air goes up and gets some speed above our heads. And then you can also see the red part in the picture is when the air comes out of the room unit in the ceiling, and you can see the air stream coming down along the wall. So this is one tool that you can use to check up if you have done the correct design, if you have a special room or a typical room that you want to design.
So this is a kind of way of securing that I actually achieve the values that we just described.
Exactly.
Yeah.
So and
if
also,
I understand, this is a really good design in this CFD calculation.
Yeah, of course.
Yeah, but it could be.
Give a good example.
Yeah,
of course, you can then go and do at external labs and so on mock-up tests to try your design as well if it's really important. And maybe that is the best one when you can look and have a feel yourself.
Yeah.
But one thing that is really important, and no matter how good you try to design the room, if you haven't a good base to start with, then it's really difficult. So you have to look at the building. And I think, Mikael, you have some...
Yeah, I would like to take some minutes and talk about the building itself, because now we have been very much into the room and the theory behind the basic stuff. But of course, the building itself is important, and that could not be neglected. We need to consider that as well, even if that might not be a part of an HVAC project. But we are definitely influenced by how the design looks for the building itself, because the internal factors are really reacting on the external factors, so to speak.
Yeah, so it's really good to understand how the building is designed and what that will, how it will affect your climate.
And for example, we talked about sun before, and talking about orientation of buildings could be definitely be one that is a game changer when we talk about design, depending on the orientation of south, north, east, west. If you're going for example, Scandinavian market where we are right now, if you have a west facade with a lot of windows, you will have a lot of sun radiation coming in because you have a low standing sun many hours of the day, and that would be different compared to if I would be in a Mediterranean discussion. So you need to understand the kind of orientation of the building itself. And of course, you also need to understand the different facades that the building is done by. You can go from a thick brick facade, which will have different thermal consistence rather than a wooden or a steel plate facade, and that will for sure change the need within the building itself. You can also discuss windows. We will talk about window and the kind of insulation capability in just a minute, and the number of window and how they are situated in the facade will also affect how we will need to handle the HVAC design within the building itself. Coming back then to sun shading, we talked about sun shading before when we were in the room. Even better is to handle the sun shading outside the facade and not letting the heat coming into the room, even if you can remove the radiation by having the sun shading in the room. Having it outside, we also keep the heat load outside. And that will help us a lot to not over design, as you talked about before. So that is clearly recommendable. And of course, that is seldom a part of the HVAC design, but it could be controlled by the HVAC design.
Yeah, exactly. We have some interfaces that we can control this.
So I think taking the building shell within the discussion as well is a very important factor to understand what is the best design for this room or for this building or for this floor level regarding HVAC design. Good. A little bit more in depth, what are we talking about? I think that the needs to be considered regarding HVAC design is to handle transmission in a good way. We talked about transmission before in the comfort part when you can feel draft close to a wall. And this is exactly what we're talking about now, the heat losses that we have in the surrounding surfaces. And that's why we need to understand walls, floor, what the floor is made of, the ceilings, the windows, the doors, all this stuff that actually are capsuling the indoor climate in reality. And that could be easy or really, really tricky. We discussed before, Josh, that it's very easy to understand maybe when you have a new building. Then you can hopefully even got the specification. But a renovation, then you start to be more guessing where we are in the transmissions. But there are some key factors and there are some tools as well. We'll come back to that a little bit later on in the presentation that will help us to design in a good manner. So we're talking about convection, different materials, and we're talking about the radiation from the different surfaces. And of course, that actually in the end will be a U value. It will be watts per square meter Kelvin. We normally talk U value when we talk windows, but there is U value all over a building shelf. And the more we know about those, the more accurate the design could be, the more accurate the calculation of effect for cooling, heating, ventilation could be. There is also other losses within the building shell, losses that it's hard to control, and we don't really want them in reality, but there will be, because no building is fully tight, even if it becomes better and better, the more modern they are. But there are always involuntary losses. We're talking about doors, we're talking about windows, and other gaps, cracks that could be in a building that will let energy both out and in, depending on where we are, which season we are in. So that is also very important to understand. If we can calculate infiltration in a good way, that will help us also to design the indoor comfort in a really good manner. Then, of course, there are some gains as well regarding energy. Most of the gains is actually those that we actually put them ourselves in reality by putting a heat source into a building, could be radiator system or fan coils or whatever. But depending on how the building is designed, the heat gains will be differ, because there will be heat gains as well compared by the transmission of the shelf itself. So depending on the ambient temperature and the room temperature, you will have gains or losses depending on the differences between them. And one of the big gains that we had touched into several times is the solar radiation. That is, of course, some part of the year it could be a plus value when we need heat sources into the building. But most of the year it's actually our disruption. It will cause us more energy to get rid of the energy or the radiation the sun creates. So that's why we talk so much about the solar shading, to be very clever in that sense, because the better we do that, the easier it will be to design the right effect in the room, for at least as for the cooling effect.
Yeah, because we know also that a lot of energy is going to cooling down buildings.
Yes.
So if we can minimize what we are cooling down.
Which probably will be one of the huge challenges going further on, when we, at least in the EU, we have the task to reduce energy. We know that in the same time, people are increasing the comfort, and we know by fact that the temperature is rising in the climate surrounding us. So the cooling needs will be higher and higher. Could we limit that as much as possible? And as you see in the screen, that you could reduce it as much as 60%, having the right solar shading.
Yeah. And I think we also have some examples here.
Yeah, this is a diagram we put together for some years ago, but it's still valid. It describes actually the building envelope from a very kind of generic perspective, that you have light building types, you have medium, and you have heavy, going from more or less wooden to brick construction or concrete. And then on the top layer you have the windows that you put into the facade, where you have a very traditional 2-glass window. There are several of them in, at least where we are in Sweden, at least in old buildings. And then you go further up into more modern windows, and you can see, if you compare a left top to right corner, you can see you double the energy use for a certain area, and I think that is critical.
Yeah.
And of course we want to sell ventilation products, but you should consider that if you invest in a good window, then you have an easier job designing a good indoor climate, actually. Because if you over design, or if you have a bad window, you will have effects on how you perceive the comfort as well. And
I think there's two phrases I hear quite a lot that almost relate to this, and one is, fabric first, and get the building fabric right. I mean, that's 101. That's of course fantastic, but also as you build tight, I mean, and the reason to do that is of course sustainability. It's clear energy is not free, it's expensive, and we all want to be more sustainable. On the other hand, we also need to ventilate buildings the tighter, and the tighter we build them, because then you can cause problems with humidity and all sorts of other things, and I'm sure we'll talk about that in some of the other seminars as well. So it's lots of factors to balance, and it's not one size fits all either.
No.
And you need to understand that comfort cannot cost it has to be balanced towards energy usage, which is very important. So I mean, you can create the perfect comfort with a really heavy energy use, but that is not what we aim for. We aim for a very smart system that is designed for exactly the need.
And one factor that we also need to talk about is accumulation or heat storage. Because if we build a building that has more of a heavy construction, then we can actually buffer some heating and cooling and get help from the building, and reduce the fluctuations in the thermal comfort, and also the energy use, of course. And you should also consider, if you build more of a light building structure, then it could work a little bit against it, and you could use more energy, of course. So this is something that you should keep track on as well, but it's not so easy. It's more abstract, so it's not so easy to relate to. So we have some very nice pictures of buildings that will help us explain this, actually. And if you look at the very old building like the Sphinx in Egypt, it's very easy to understand that this is a heavy construction, and it will store energy in a good way, and it can also keep and balance the energy, so you can feel have a good climate indoor. But for us, that is also quite old. We also have learned about how it is to be standing in a telephone booth in London, Josh.
Apparently so. I've never used a telephone booth.
So, but if you're standing there and the sun is shining, you get very warm immediately. So it's a very light and transparent building. So that is the same thing when you design a building. You have to consider that, how it could work with you or against you in doing a right indoor climate. But generally, you could say that a medium size heavy building is you can calculate for 10 to 15 watts per square meter in accumulation. That can help you.
I think that could be a really good rule of thumb.
Yeah.
To remember that that is at least what you can expect in some way. But remember, it can be both for you, but also against you.
Exactly. And how can you keep track of all of this? Well, here in Swegon, we have a calculation tool that helps us out really early in a project phase. And of course, Swegon ESPO. And ESPO stands for Early Stage Building Optimization. And it's a tool for energy calculation. So you can go in there and calculate the energy use of your building and your project. And this is developed together with a company called Simulation. And it's a simplified version of their software called EDA-ICE. It's a neutral software base here. So you should know that. And there are several different tools of this kind on the market. And we would recommend you to use that. Start in the project. Just don't use your old rules of thumb because things changes. Sometimes you get more people into an office floor because you need to design it in that way. And sometimes it's less, and then you have to calculate what energy use you have. It's also adapted our calculation tool for demand control systems as well, which is also a good thing because if you're aiming to get LEED or BREEAM Platinum, you need to have a demand controlled system installed. And this is a good tool that you can use to discuss with different groups of interest in the building project really early in the building phase. And you can also choose what ambition level you have. You can do one room only, and if that is critical, if it's the manager or an important person room, then you can choose that and design and calculate around that in more detail. Or you can choose to create a room floor, a room floor plan, or a complete project, of course. So you can choose different levels and make a quick calculation or go more into detail. And you can also really easy make realistic calculation what happens during the day. You can put in the orientation of the building, northwest facade, the type of glass, and you can put in the office hours when people are coming and going and the level of occupancy in here. And you can create different set points and flows of the air and so on. So everything you can put in there to get a realistic calculation as possible of the design.
Yeah, and just as also says, this is a tool, and we're describing one of them now, which is important. But it's so important to understand what we had described in the presentation, how you can actually apply them in reality to understand the system part of HVAC design. And I think the kind of energy software calculation tools like this would really guide you to the best solution, and to the, I would also say, to the most energy efficient solution. So you're actually balancing the comfort level with the energy users, and you will have a good selection software that helps you to do the right solution in the end. And of course, comparing, as you say, also a constant air volume with the variable air volume or demand controlled air volume. See what in this project what suits us best. There is no one and only answer.
Exactly.
It's not one size fits all. It's definitely depending. It should be tailor-made to the project that you are working with right now. Or of course you can change different setups as well, as you see in the screen, airborne versus waterborne, for example, or maybe hybrid version as well. And I know for a fact that this will be a part of the next webinar as well, so I will not go further into that discussion.
Another cliffhanger for us.
Yeah. So just keep on tuning in. And I think the important thing is from this is that you will have a result, you will have an energy balance, you will see how the user phase of just this building or this room, depending on what you are calculating, will actually, how it will look like in reality. So it will definitely help you to choose a good system. It will actually help us also estimate operating costs. So you will have the monetary part of it as well. And that could be also the game changer, actually, depending on your electricity cost or whatever cost you have regarding energy. And that could change the whole setup. And as you said in the beginning, you told early design tool, something like that. And I think this is something that needs to be pointed out. The earlier you can do this kind of calculation, the earlier you can have this kind of discussion from a comfort perspective, the easier it will be to adapt, the easier it will be to change, to have the optimized solution. The later in the process you will come, the more costly it will be and the harder it will be as well. So this is really our very early tool to really guide us to do the best of the situation we have in front of us. And I think to conclude that, this is really a good pillow, because finally all of us want to sleep well. And I think this is actually helping us to do that in reality. Yeah, Josh, what do you say?
Perfect, fantastic, thank you guys. And I guess you could also say there's a bit of a duality in the, you know, if you're a consultant and you do the good pre-work and you've got all the analysis, you can sleep well at night, knowing that your building's going to be successful. And you could probably say if you're a hotel guest in the building that you've designed, for argument's sake, they will also sleep well. So that's great. That's and we'll come back to you with some questions in a second. But I just wanted to wrap up a few things. So if people have questions, please do send them in the Q&A box, and I will feed them into also Mikael, and we'll answer as many as we can. But just to wrap up a few of the key points, I mean, thermal climate, we said it was actually one of the biggest source of complaints in buildings. We've given you some of the key terminology, the key things you need to know about. We've spoken a bit about the building envelope and the building fabric and how important that is to get the outside right. And then we've spoken a bit about modeling and giving ourselves the right sort of information in order to make a good decision, balancing all the things like capital cost and energy cost and so on. And ultimately that can all reduce project risk, because you know, the later we make decisions, the more costly and complicated that can be. So that's all of the material from our comfort seminar. Coming up next in a week's time, we've got a seminar where we're going to talk about ventilation and ventilation principles. That's on the 16th of June. And then on the 22nd of June, we have a seminar on acoustics as well, which is I'm really looking forward to, actually. So that should be really fantastic. So thank you for listening. If you want to sign up for the other webinars, they're on swegonairacademy.com. You'll also get a copy of the slides and the material from today by email. So I'm just going to have a look now and get the question for you guys. I had one come via the chat, actually, which was, I'm going to paraphrase slightly, which is, how do you check that the operative temperature is acceptable? Presumably this is in existing rooms without using CFD. Is there an easy way someone can measure the operative temperature?
That is really hard to do. But normally it's 1 to 2 degrees below the measured air temperature that you have in the room. Yeah, but then if you have the knowledge that you know that you are influenced by different things, you can also easily check what could be a source of complaint, if it's the window they're sitting too close to, or if it's the air velocity or something.
Yeah.
Yeah, but I totally agree with that. And that's the hardest fact, that you can't go with a temperature sensor and measure the operative temperature. It's based on know-how in reality, that you understand the surroundings, that you understand the situation, orientation that we talked about before, what could influence. So it's a very important value, but it's calculated.
Yeah. We talked a little bit about the occupied zone and where we measure. I had a question about whether that applies to sort of even buildings with huge ceilings, auditoriums, or it has a big glass atrium. Does that change the occupied zone in any way? So it's always the...
No, it's a very easy answer. No, of course the challenge will be different depending on how the room is designed. But it's always the occupied zone that is the value base for the design.
Yeah.
But there are, of course, depending if it's a high ceiling and or if it's an auditorium, there are different challenges managing that design, of course.
Yeah,
of course, absolutely. What about working with renovations? Obviously, in the software, you can provide a U value for new products, and they're often a known quantity. What about working with renovations?
But that's a valid question, I would say, because that's not so easy. There you need to be more generic. You need to accept that the fluctuation in the result will be larger than in new build, but you still need to try to get as close as possible, and that's why the most software have a kind of generic base that you can at least choose light, medium, and heavy construction phase, because that you might be able to judge based on the building itself. I mean an old 1800s century building, mostly done by bricks in most part of Europe, so probably heavy construction. A building in 1970 in Sweden will for sure be wooden, and for sure light. So you can at least play with those, but you can also in the software, the different tools, of course, change it and see how much does it affect in these circumstances, because you need to add the windows as well, you need to add the square meters. So in sometimes you have a really large effect on the kilowatts that you need to put in there. In others, it doesn't affect that much. So
maybe I should put the bigger part of the budget on like insulating the facade or the windows. And then you can install a smaller HVAC system to get a good comfort anyway, instead of installing good radiators or big radiators or big room products that is over designed. So you will risk draft and discomfort.
Yeah, and to be catching to what you say, over design we don't like.
No.
Because it also makes it's very hard for the building automation system to stay in a certain range. It will be easy that you have a kind of jumping curves, even if you try your best, because it's so much effect that should be out there providing energy into the building, cooling, heating, that is hard to regulate in a good way.
Yeah. And then I have a question which is actually really, really interesting, which is what could be done about the difference between men and women in buildings and the design and building standards, which, as we covered in the last seminar, sometimes are not so friendly to women because often they're old standards based on men. In future, do you expect that we will design different types of building for women, or do we have any insight we could share?
Maybe not the different kinds of buildings, because that would be
strange to have a male building or a female building.
But
you're touching into something very important. And to be really transparent, we also done some internal studies within our group of company that actually points out that there might be a difference in how you perceive comfort within a building. So
So we will look into that
yeah,
later on and do a webinar.
We are planning a webinar in the autumn just on this topic. So it was not on the list, but we stay tuned on airacademy.com, and then we will publish news about that as well. For sure, there are science and there are studies showing that there might be something there that we need to take into consideration.
Yeah, and Carl's just dropped a message really helpfully, actually, saying ASHRAE 55 has recently been changed to recognise the different needs of women. So I haven't read that.
No, me neither, but it's good point.
So thank you, Carl, for sharing that. That's really, really good to know. Good question from Lewis on the performance gap. In your opinion, how small do you think the building performance gap can be reduced to by building simulation?
I think it could be reduced quite a lot, actually. We have had some projects that we have a design of 80 watts per square meter, and then they are running a performance checkup, it's down to 40-50 watts per square meter. Yeah, and I think it's due to maybe demand control ventilation, solar shading that is active and controlled together with the HVAC system.
Yeah, I think our experience is that when using the different tools that we presented here, like CFDs, but also, of course, the energy balance calculation tools, that you will, first of all, you will have a very interesting discussion in the project. What is the best solution? And I think our experience is that it really helps to find the best solution. The problem is that you can't really say that if, say, 80 watts per square meter, that will be the final result, because that depends on the project itself. Are they following the design that was kind of put on paper in the beginning? Are the user stays the same as decided, or do we suddenly have a gym instead of an office, etc.? So you have to be balanced there, but it should for sure help us to make the right choices. So I think that is the key here.
Yeah, and I think also if you use these kind of softwares, you can also do a follow-up, because I think that will also become more and more important with these certifications that we have on the market, that we also check up the operating and maintenance part.
Which you actually see a lot of the certification now has a running certification as well, and there are, as far as I know, some legislations that actually are putting this as a suggested legislation further on, that we should have a kind of operating result as well. And that I totally promote that. I think that's a really good solution.
Excellent. So thank you, Åsa. Thank you, Mikael. Really, really good presentations. But thank you for joining our seminar today, and have a lovely evening.